Okay, class. Hello. Um, let's start off with section 2 of chapter 1. And now we're going to look at some of the applications of linear equations, okay, as well as rational equations as well. So when we look at algebraic equations, or applications in particular, they're typically used in every aspect of our lives. Um, Moreover, they involve these linear equations which are used typically to solve real life problems. Um, so real life or real world problems, they come in a word fashion. Okay? And we can turn these word problems into algebraic expression. And we'll show you how to do that in a few minutes. But there's typically like a plan you kind of want to put together when you encounter these word problems. First of all, you want to understand the problem first of all. Devise a plan, carefully solve the equation, and you typically want to be able to check your answers like we did in chapter 1, section 1. Check your answers to make sure if they make sense or not. That's very, very important. Okay. Within this section, objective 2 really moves into solving applications. Um, in this case, you always want to ask yourself, what are they asking, or what's the question asking? Okay. They want to know how how many touchdown passes between Staubach and Bradshaw. Okay, so this problem is in your textbook, um, and kind of look at the question itself. But when you look at example 2 under objective 2, they're really looking like how many touchdowns passes between Staubach and Bradshaw. Okay. So our plan in this case really is to devise a plan. Let X be Bradshaw. Okay. Since Staubach threw three more than twice as Bradshaw, we can formulate a simple linear algebraic expression looking like this: 2x, x being Bradshaw, plus 3. Because why? Staubach threw three more. That more, in this case, is a plus sign. Three more than twice of Bradshaw. And Bradshaw, we said, we let that be equal x. So that gives us a 2x plus 3 expression. And we know that the total number of touchdowns is 33. Okay, so we can set up an algebraic equation, linear to be exact, x plus, in parentheses, 2x plus 3, which is for Staubach. I hope I'm pronouncing the name correctly. And then the total amount of touchdowns. And we can solve for x from that point on. So once we solve for x, we'll know how many passes Bradshaw threw and how many passes Staubach, touchdown passes Staubach threw as well. Okay. Now, does this answer make sense is the fundamental question. Okay. Again, what's on the left-hand side must equal what's on the right-hand side. Okay. So 10 plus 23 equals 33. So therefore, this particular answer makes sense. Okay. Now let's move on to another problem. Okay. This one, we are asked to determine the unknown numbers. Okay. One number is 3 times another number. Right. Determine the two numbers if the sum of the reciprocal is 4. Okay. So the question, again, going back to our plan, what is the question asking? It's asking us the sum of two reciprocal numbers, right? And that happens to equal 4. What are these two numbers? Okay. So what's our plan? Okay, well, let another number equal x. Let one number equals 3 times another number. And that'll be 3 times x. Okay. And we know that if x is another number and the one number is one of those two numbers is 3x, So we can put it together equation x plus 3x equals 4. Okay. And now, but they told us that it was the reciprocal though. These two numbers that we add up together they are reciprocals, right? And they equal 4. So we have to change their formation into reciprocal form. Okay. So instead of being x plus 3x, it's going to be 1 over x plus 1 over 3x. And then here we can do the algebraic equation. Okay. And then we get x equals 1 over 3. Okay. Now, if you're having any issues with getting from here to here, please let me know, and I can help you understand that process. But if you don't say anything, I'm assuming that you know how to get from this stage to this stage. Okay? If not, there's nothing wrong. We can just go through it together, and I can help you. Okay? Now, once we find out what is our x, which is 1/3, now we want to find out, does this really make sense? Okay? So we go back and plug this x into our original equation, just like we did in section 1 of chapter 1. We know that if x equals 1/3, we want to be able to plug it back into this value here and into this value here, right? So when you do that, it looks something like this. Okay? And remember, when you have an expression looking like this, that means 1 divided by 1 over 3 equals 1 times 3 over 1. Okay? Which happens to be 3. Okay? And likewise, we do that for this expression as well. Okay, so what's on the left-hand side equals on the right-hand side. So our answer makes sense. Okay. Let's go to another exercise problem. In this case, we're going to be able to solve applications involving geometric formulas. Okay, so we have an equilateral triangle that has a perimeter of 50, right? If two of its sides are equal and the third side is 5 more than the equal sides, what is the length of the third side? Okay. So our first question is, what is the question asking? The question is asking us to find the length of the third side of a triangle if the parameter is 50. Okay. Well, keep in mind that a parameter is when you add all the sides of a polygon. In this case, this polygon is a triangle, so you add all the sides up. Okay. And if you add side A plus B plus C, our parameter is 50, as they told us, right? Well, if two sides are equal and the third is 5 more than one of the equal sides, then we can set up our algebraic equation. Okay, our parameter equals one side, two sides, and the third side. Well, we know one side is going to be x because they're equal to each other, right? And it's going to be 5 more plus one of those sides, which is going to be x plus 5. So once we have set up the algebraic equation, or expression I should say, we can solve for x. And when you do so, you get x happens to be 15. Now we can go back and check to see if it's so, right? Because if this is going to be our setup, where we see x, we can plug in 15. Because x is 15. Okay? So x, that's 15 plus 15 plus 20. Okay? That gives us 30 plus 20 happens to be 50. So what's on the left-hand side equals on the right-hand side. Okay. Let's look at another application of word problems. We want to look at mixtures, money, mixtures, and interest. Okay. So a bank teller has 180 bills consisting of $20 and $10. If the total cash value is $3,050, how many of each type of bill are in the money drawer? Now, what is the question asking? Okay, so the question typically is asking us, we have a money drawer that has a table, there's a total, I'm sorry, of 180 bills. And of those bills, um, we have, they consist of $10 and $20 bills, right? And they equate to $3,050. Okay, so our strategy could be, well, let X amount of bills be 10, right? And what's not 10, let that be subtracted from 180, which will equal to the $20 bills. So we can say X, which is, we equate it to 10, plus 180 minus X will give us that total number of amount in terms of the bills, 180 bills, which is 3,050. So when we do this, we can do the math. Right? In this case, we're multiplying the 10 by the X. Is 20 by 180 minus X. And when we do that, we're typically going to get this expression here. When you solve for X, you're going to get X equals 55. Okay. Now we're not done yet. So if the number of $10 bills is 55, how many bills are $20 bills? So we can do 180 minus 55, which is 125. So we have 155 $10 bills and 125 $20 bills. Okay. And let's look at mixtures. So our mixture question says John has 20 ounces of 20% salt solution. How much salt should be added to make it a 25% solution? Okay. So again, what's our plan? Our plan is to ask a question, and the question states that John wants to add a certain amount of salt solution to reach 25% from 20%. How do we go about doing that? Well, let X equal the amount of salt added. 20% of 20 ounces, of course, can be written this way, right? Therefore, you're going to have 20% of 20 ounces plus the amount of salt being added equal to the total amount that he wants to see. Okay. Now we can solve this algebraic setup, and we can just open up after we've done the multiplication, we can open up the parentheses, add it to X, and then we can actually expand the right hand side of the equation. And when you do so, you're going to get X equals 1.33 ounces. Now again, check your answer to make sure this is so, because if the right hand is not equal to the left hand side or vice versa, our value that we found as a solution would not be true. Okay. And last, let's look at an interest problem. Okay. Mary invested a certain amount of money at 10% interest rate and 2,000 more than at 12% interest rate. Her total yearly interest earned about $1,340. How much did she invest at each rate? Okay. So the question is asking us, how much money was invested at 10% interest rate? How much money was invested at 12% interest rate? So the plan that we can use to actually create an algebraic expression would be let X equals the amount invested. And let that X be at an interest rate of 10%. Well, the second rate can be X plus 2,000. Why? Why would that be? Because it says here that the money that was invested was a 10% interest rate and $2,000 more than at 12% interest rate. Okay. So right now we can set up an algebraic equation, some unknown value of money at 10% and some unknown value plus the total amount at 12% equals 1340. When you actually do the algebraic expression, again, you can solve like terms, and this 240 goes to the other side of the equation. Solve for x, and that gives you 5,000. Okay. Okay. So the question now becomes, uh, let me see something here. And we want to divide that by 0.22. That's 5,000. Okay. So our x happens to be 5,000. Okay. Okay. I hope this helps. Kindly let me know if you have any questions. And these word problems can be somewhat intimidating, but if you break them down into an algebraic expression, you know it's home run from there. Okay, it's just a matter of just breaking it down to where it makes sense. Okay, kindly let me know if you need any help. Thank you very much.